Hi, I'm back again, and today we're going to be talking about lines and planes. I've got two amazing videos coming up for you. In the first one, we're going to be looking at the point of intersection, and the second one, we're going to be looking at the angle between a line and a plane. So let's visualize what's happening here. We've got a situation where we've got a plane, you can see the plane in purple, and we have a line in three-dimensional space that's passing through that plane. And what we need to do is find the point of intersection. So we're looking for that exact point right here. You can see it, where the plane is intersected with the line. So this is the equation of the plane, pi, this is the equation of the line, L. So what you're going to do is you're going to set up your parametric equations according to your line. So in this case, I would have x is minus lambda, because it's 0 minus 1 lambda. Y is going to be 1 minus 2 lambda. Remembering this is my equation for x, then y, then z. Okay, so my last equation is going to be 2 plus lambda. Okay, so I've got three parametric equations, and what I'm going to do is I'm going to substitute my equations for the line into my equation for the plane. This is really beneficial for us because then we're going to have one equation in one unknown, or in lambda, and we'll be able to solve for lambda. So instead of x, I'm going to put this here, I'm going to put this here, and I'm going to put this here. So one at a time. I've got 1x, so I've got minus lambda. I've got 1y, so I've got plus 1 minus 2 lambda. And I've got 1z, so I've got 2 plus lambda. And this is all equal to 1. Okay, let's tidy this equation up. I've got minus lambda, minus 2 lambda, that's minus 3 lambda, plus lambda. Okay, so that's minus 2 lambda here. Okay, I've got 1 add 2, so I've got add 3 is equal to 1. I'm going to subtract 3 from both sides. Minus 2 lambda is equal to minus 2, so lambda is equal to 1. Now remember, that's not the solution that we're looking for. We're looking for the actual point. But all we're going to do now is we're going to go back to these three parametric equations we've set up to find the x-coordinate, the y-coordinate, and the z-coordinate. So x is minus lambda, x is minus 1, y is 1 minus 2 times lambda, and z is 2 add lambda. So x is minus 1, y is minus 1, and z is 3, and you can write that as a point. Minus 1, 3. And that is all done. You found the point of intersection of a plane and a line in three-dimensional space. If you found this content useful, if it helped you to study for your next exam, please like and subscribe.